Hi, welcome to second video in Angular Signal Learning series. In this video, we focus on computed signals and effects. Before you start watching this video, I request you to go through the first video of this series. You can find link of the same in the comment below. So in this video, let's start with computed signals. Now, what is computed signals? Computed signals create derived values based on one or more dependency signal value. So computed signal always depends on one or more than one signals. A computed signal can be created using a function computed, and as you see on your screen that in Angular this computed function actually returns you a type signal. Keep in mind, signal function returns you a type writable signal, means you can read, write, update and mutate a writable signal. However, you cannot perform update and write and mutate operation on a computed signal. Computed signal are read-only in nature. So as you see on your screen that the computed function which we use to create a computed signal returns you signal of type signal. So a computed signal derives its values from other signals, and we are going to create a computed signal in a bit. But before we move further, the main characteristics of computed signal are that it is expected to be side effect free. And to understand that, try to subscribe to a behavior subject and try to read value of a signal, computed signal, and then you can see the comparison. Probably in some other video I can cover that. Computed signal should avoid mutation. It should not write to other signal. That is very important. So if you try to write to other signal inside a computed signal, Angular complains about that. Computed signal, like a writable signal, can have an optional equality function, and we would cover that in other video, and it is not writable. It is read only. You cannot write to a computed signal. So let us, and these are another four characteristics, that computed signals are lazy. Computation are disposed of automatically, so you do not have to worry about that how to dispose computed signal. Computations are glitch free and it is memorized. So let us go ahead and start creating a computed signal, and then we come back again and go through these slides. So here I have created a signal called count. And again, if you are new to Angular Signal, please go ahead and watch first video of this series where in detail I have explained how to create signals and all that. But just to summarize, to create a signal, you use a function signal, and that returns you a type writable signal. Focus on line number 33 here. So you create a signal in Angular using a function signal that takes an initial value and it returns you a type writable signal. Means you can perform, set, update and mutate on this count. So here I have created a signal called count, and initially that value is 99. Now let's go ahead and create a computed signal out of that. So let's say that we call it is odd. So I'm creating a computed signal called is odd, and that to create a computed signal you need to use a function computed. So here I'm saying that computed, and that takes a function here. Now we call it here that, hey, if this dot count, and read that, we can say return, if it is this dot count is equal to 0, then return even, else we return here odd. Okay, so here we are saying that is odd is a computed signal, and is a computed signal which depends on the count signal because we read that value here, and then we return some string here which is even and odd. We can say that is odd is of type signal, and we are expecting it to work with type strings because that's being returned here. Now on app component HTML here, let's go ahead and say that h2, and then we say this dot count is this dot is odd, like whether it is this dot count, that signal value is odd or even, we should be able to get that. But before that, let's go ahead and add a button here which would update that count value. So here we are saying that update count, and this button, on the click of this button, you say update count. And let's go ahead and create this function here. And here I have a function update count. And what that that function I do, I say this dot count dot update. So whatever is the value, just increase it by 1. So here we are updating that count. Alright, so now here in the output, you see that it tells you that 99 is odd. When you update the count, 100 is even, 101 is odd, 102 is even, 103 is odd. So what we have done, how you create a computed signal, here you use computed function, and then inside that you can read more than one signal. Please keep in mind, it's not that it's one-to-one relationship between a computed signal and a signal. You can read more than one signal. However, here we read only one signal count. We have put some little business logic, and then we return a string depending on that business logic. And then we use computed signal in the way we use a signal. Means you can read a computed signal exactly the way you read a signal, which we do here. This dot is odd. Now keep in mind that computed signal is lazy in nature. What does it mean? So to understand that, let's go ahead here in the this dot count, and let's say that you say that console dot log, and here you say computed, and then put the same logic in the else condition as well. And then now if I go here and press F12 and go to console, you see that that computed is being printed there. So it's working. Now let's go ahead here and remove this dot odd. Means you have created a computed signal, but you are not using it yet. Now here you go that you don't get that computed printed here. Means computed signal is lazy in nature. It only gets evaluated when first time you read its value. Since right now we don't read that value, we are not reading that value, even if computed signal is created, it is not being executed. So please keep that in mind. Now as soon as I go and read this and then come back here, you see that Angular has read that that computed signal, and then here you can work with that. So that's how you create a computed signal. Next is that this computed signal is read only. Means you cannot set value, cannot update inside computed signal. So here if we say that, hey, this dot is or dot set, let's say 99, if I try to set that, I get compile time here error here that property set does not exist on type signal because computed is read only nature. You cannot perform set operation, you cannot perform update operation, which you again get error here, and at the same time you cannot perform mutate operation. Keep in mind all these three operations can be performed on a writable signal. Means a signal which you create using signal function. However, computed signal is read only. You cannot perform set, you cannot perform update, you cannot perform mutate. So that's characteristics 2 you should remember. First is lazy in nature, which you just saw in the demo. Second, it is only read only. Third characteristics of a computed signal is that you are not allowed to write to other signal inside computed signal. So let's say that if I have one more signal, I create a signal called foo, that is also a type writable signal, and I say that by default that value starts with 100. And if inside this computed signal I say that this dot foo dot set, and let's say that I'm setting that value to 300 here inside this computed signal is odd. Now you see that here it tells me that writing to signal is not allowed in a computed or an effects by default. So you cannot write to another signal inside computed signal. So here this line is causing you error. That's characteristics number 3 of a computed signal, that you cannot write inside a computed signal. It gives you error here. If I get rid of this line, everything is fine and I can work with that. So here is as simple as that. You created a computed signal, they are lazy in nature, you cannot perform write operation on a computed signal. You cannot write to other signals inside computed signal. And keep these 3 things in mind when you work with computed signal. Next we are going to see effects. Effects. An effect is a side effectful operation which reads the value of 0 or more signals and is automatically scheduled to be rerun whenever any of those signals changes. So effect is a side effectful operation, that's one. Second is that it is automatically scheduled to rerun. So keep in mind that it does not run whenever the value changes in the signal. It is scheduled to rerun sometime in the future. So that's what effects are. You create an effect using a function, using the effect function, the way you create signal using signal function, create computed using computed function. You create effects using an effect function. So effect is created as you see using the effect function. Now these are the few points you need to keep in mind about scheduling of an event, like when effect gets executed in Angular. Effects run asynchronously during the change detection process. So right now, as of now, effect runs during the change detection process. Effects will execute in response to their dependency changes at some point in the future. So it's not that as soon as signal changes, effect runs. Effects are guaranteed to run at least once, sometimes in the future. Right now it is tied with the change detection process. Effect always runs at least once, and effects will execute a minimal number of times. So the guarantee is that it is going to execute minimal number of times. So these are the 4 points you should keep in mind about the scheduling of the event. Effects, that it is tied with the change detection process. It is guaranteed to run sometimes in the future if the changes happen in the signal. Effect always runs at least once, and effects will execute a minimal number of times. That's about scheduling of the effects. The effect execution timing is not guaranteed and is unspecified. So developers should not depend on any observed execution timing. So this slide on your screen is very important, that effect execution timing is not guaranteed and is unspecified. So developers should not depend on any observed execution timing. So you got to do something which is very deterministic. You should not do that inside an effect. These are the effect use cases. You can do trigger network request. You can do the logging of the data being displayed. You can perform some custom rendering, etc. inside effect, and we may cover that in further videos. But as of now, just for your information, these are some of the use cases to use effects. So like computed, you should not write inside an effect as well. We are going to cover that. So let's start with creating an effect. Keep in mind that an effect gets created. You can only create an effect inside an injection context. Means you cannot create an effect anywhere. The effect needs an injection context. So what does it mean? That means is, let's go ahead here and open that. So let's say that if you want to create an effect, here you say that effect, and if you create effect here, Angular does not allow you to create that because because you cannot create that outside of an injection context. So you can create an effect inside a constructor. So here we can say effect. So constructor is an injection context. Here you can say console.log and this.count. So here this effect depends on this count signal, and you have created that inside a constructor injection context. Another is that you can create that inside a function as well. For that you have to pass. So first let's see that how this effect is printing the value in line number 52. Here it tells you that 99. As you see that you are able to read that. You cannot write inside an effect like a computation. So here if you try to write this dot foo dot set and say that okay 30, what Angular does that it complains you that hey, writing to a signal is not allowed in a computed or effect by default. But if required inside effect, you can override that. You can say allow signal write and can say true. So you should know that what you are doing. If you set this value to true, you should able to write to a signal inside an effect, and here you see that it is working fine. You are able to write to a signal inside an effect by setting this value allow signal write true. Go to this effect here, that function that takes a effect function, and it has as you see that it takes a cleanup function as well. Means since effect is tied up with the injection context, whenever that injection context is destroyed, that effects also gets destroyed. But if you need to manually clean up an effect, you can also do that by passing on cleanup to true. Now let us see that how we can create effects in other ways. You can create an effect inside an injection context. One injection context is the constructor, so you are able to create that inside constructor. Let's say that you have a function, like you have a function called create effect. You can have any name, and inside this function if you want to create an effect, so use effect function, and then here we say console.log this dot count, and then here let's call that function this dot create effect. Okay, so when we run this right now, it tells you that effect can only be used within an injection context such as constructor, a factory function, and all. So, but here we have a requirement to create inside the function. What we do, we go to injector here, and then we inject injector. So here we inject the injector in the constructor of the component, and then here as another parameter we pass this dot injector. So here we are passing the injection context, and it should not complain that, and here you see that console.log count, line number 68 returns you 99. So you can create an effect inside a method as well, inside a function. For that you have to pass the injection context. So that is one way of creating. Another is that of course you can create that inside the constructor. That is second way of creating. Third is that you can assign an effect to a field. Means you can say here that okay, e equal to effect, and you can create an effect here as well. So console.log, and let's say count e is this dot count, and here this is the third way. You are assigning that effect to a field, and you are able to get that count E99. So you can create an effect in three possible ways on a component. One is that of course inside a constructor. Second is that you can assign an effect to a field, and third is that you can create that inside a function, and for that you have to pass the injection context, which we are passing it here. So first we injected it here in the constructor and then passing it. So this is the three ways you can create an effect. Effects are always live. They only get destroyed when the injection context in which it is created. But if you have to manually, if you want to manually clean up an effect, you can do that. For that, here in the constructor, we are creating an effect. So let's say that I call it as A. So here I have AN, and here I say this dot A is equal to effect. and then here manually we can say manual cleanup true. So here you can pass this manual cleanup true, and then whenever you want you can destroy to that. Let's say on destroy, and then you have this on destroy lifecycle hook. Here you can say this dot a dot destroy. So you can manually clean up an effect as well. For that, here you can say that manually cleanup is equal to true. If you really don't have to do that whenever in the injection context in which effect is created, when that dies, that effect also gets cleaned up. But just wanted to let you know that if you have to, how you can do that. So you learn that an effect is again it is the side effect. You don't know when it is scheduled to run, but it runs sometimes in future. As of now it runs with the change detection. It is tied up with the change detection to execute whenever something changes in the signal. There are multiple configurations which you pass to create an effect. You can pass allowed signal rise true, you can pass manual write up, manual cleanup, and then you have here then you can create an effect inside injection context. Best is that you create that inside constructor, but you can create that inside a method. For that, pass the injector as a second parameter, which we are passing it here, and you can create that and assign that to a field as well. So I hope in this video you have some deep learning about deep API learning about computation and effects. You already know about signal, so you know about signal, you know about computation, you know about effects, you know about their characteristics, and you are now ready to use them in your project as and when required. In next video, I would cover more real-time scenarios and RxJS interoperability with signals. I hope you like this video. Thank you so much for watching it. Thank you, and please subscribe to the channel so that I get motivated. Share this video with your friends, and like and comment as they say. Thank you so much for watching this video. Thank you.